All right, we're recording. How's everybody? Hey, Frank, Aaron, Mitchell, David, Jacob, Oliver, Roberto, YL. Hey, Renato. We've got to fix that name, Guerrera. Hey, Adam, Joaquin, Greg, Ari. Hey, Mark. Okay, so what are we focused on today? Let me get my screen drawing program started. Again, we're going to follow the format where this live lecture introduces the concepts and things that the recorded stuff is going to lay out for you and just be like a more solid process. But before we get into that, hey Roberto, before we get into that, I just want to check in with you guys on the course projects. And we've made a couple of changes, so I also want to just check with you on the discussions and the site and all of that. If you're looking at my site and yours is not the same, it's because I'm logged into the admin. Normally I wouldn't do that, but this morning got a little out of place. So you're just looking at admin stuff, so you can ignore a lot of this like course edit and yada yada. Okay, so I want to see how are the projects working for you guys. I see you posted a ton of them, which is fantastic, and that you're interacting and commenting on each other's. So give me a shout out. Let me know. How's the projects working for you? You able to upload okay? You able to see everything okay? Did you have any problems with the assignment, the sculpting, the head sculpt? I know you might be typing right now, part of online. Frank says the project was tough to start, but once I got cooking, it was fun. Tell me about it. Resistance. It's our constant battle. Aaron, your system could use more RAM, which just means you could get more polygons. That's great. Understand that. Norman says working from a good reference is everything. And you know what? I have to second that. It was something I noticed in a workshop at Richard McDonald's studio. He didn't work with just any old life model. He worked with Cirque du Soleil performers and people that he flew in to basically to model for him. He had a couple of, I think he had one or two models that were always available, but the primary efforts were with highly skilled acrobats, gymnasts, I should say. The better the model, the better result. You know, they say garbage in, garbage out. What you put in to your artwork, including your time, your reference, your own knowledge, you know, can't help but affect what comes out. Rebecca's struggling with eyelids. I understand that. Rebecca, the eyelids get so confusing. You know, where do the eyelids meet the side of the head? You know, what happens there? It can get so confusing because there's all these words like the frontal sphenoidal process of the maxilla, and then there's how's the bone connect to the eye? How does the skin bridge that? And then the eyelid itself, the technical terminology is called the palpebral ligaments. And it's just a ligament that's kind of slit in two so that you can see through it, but it's the upper and the lower eyelid. And how they connect to each other, how they create the caruncula, you know. It's a constant battle. But we have ways to simplify, to make our lives easier. We don't need to understand the anatomy, and sometimes understanding the anatomy doesn't help us as sculptors create form. So today, don't let me forget, I want to show you a trick in how to create eyelids and things like that. Without having to know the anatomy, there's just some cool tricks for creating the form itself. And Gabriel, there's a saying that the difference between a good sculpture and a great sculpture is just a little tiny piece of clay. A little tiny piece. It's all about subtle plane changes once you get at that level. Andrea, glad projects are working for you. Roberto's looking to put planes in the structure of the face, but finding it hard to get good reference. And yeah, I understand that. It's a constant battle because you have to grow your brain. There's this I was talking to somebody on the team about this. You know, you can Google how to build a TV, but you can't really Google how to sculpt a face and expect to be able to sculpt a face. You know, if you Google how to build a TV, you have a reasonable assurance that, you know, if you have the tools, you're going to be able to build a TV. You know, you might have to buy a couple of pre-made parts, but you're going to build a TV. You want to sculpt the head? You want to paint a head? Art doesn't work that way. It's like tennis. It's like, you know, it's like a sport. It's like something along those lines. Knowledge is different than action in this case. So we have to learn the knowledge, and then we also just have to do it so that it gets into our brain in a different way. And we have to look for what we're going to talk about today, which is look for systems that kind of help us do things. All right, just a couple more questions I'm reading. Renato, my girlfriend is jealous of ZBrush. Yeah. Jacob, fine brows and cheekbones the toughest? You know, Jacob, if you sculpt the brow and the cheek as though they were the skeleton, I think you'll find things improve. Just grab a skull, get a skull. They got $20 skulls on Amazon. Any old skull. Or you go over to our friends at Anatomy Tools, or a bone clone if you're looking for bones clones, if you're looking for like the premium package. And then also don't forget, I posted this in a couple of people's projects, hauntedstudios.com. I don't know if there's where they're operating now because they were in transition, but they, in fact, let me put Haunted Studios. I have about 5 of their life casts in the studio. Angelina Jolie, Johnny Depp, and a couple of others. Can't beat the deal. Crazy cheap for everything you get. I think somebody was sculpting a Patrick Stewart, and there's Patrick Stewart. So there's a lot to learn from Patrick Stewart's face. One of the things you learn is how much like the bone his brow and cheek really is. It's really just bone. The surface of the skin and muscle, something like 5 millimeters in the brow and cheek area. It's like 20 millimeters down here in the muzzle of the mouth. 5 millimeters is not a lot. It's basically bone. Norman, skin folds. You'll want to check out, Brian Wade has something on skin folds. Okay, just a couple more. Aloha. Hey, Chris. Where did you want me to view? Somebody wanted me to view in a larger. Not that, they're just using Magento here, I think. Okay. All right, so great. I'm glad you guys have posted. This is a ton of projects, and this is a lot of great work. So I'll go in here and comment on everybody's work after the class as well. Try to make sure I get at least one comment in there. Really important to write what you think is good, what you think you can do differently, and then rewrite what you think is good. This is really important for the process. Not for the class, it's for your mental process. And that's learning to sculpt, learning ZBrush is about learning how to sculpt. I can't say that enough times. That's both on just the fact that you're sculpting inside of ZBrush, but it's also from the side of the developers who are very focused on, how to make sculpting inside of ZBrush as natural an experience as possible. So I'm in ZBrush now. We're going to get started. I've got Lightbox open, and I'm just going to open up the default sphere. And I'm going to move over to the Cintiq now. Oops. Okay, so let's give ourselves a little bit of understanding of what we are doing. So last week we focused on really just the getting started. And so what getting started involved was like 3 brushes, interface, and then just simple workflows. You remember we had a conversation about when we were doing the eyes, there's multiple ways to do eyes. You can use subtools, you can do all these things, but I was trying to keep it real simple so that anybody would be able to follow that without having to learn a new interface item such as subtools, and then all the complexity that can kind of entail. As you go through ZBrush, the learning process, you might, what I hope I can kind of share with you guys is how efficient ZBrush is. There's never a time that Pixologic or the dev team is sitting down and they're like, hey, wouldn't it be really neat if I do X? Like, hey, wouldn't it be really neat if there was a brush that could, cut a model in half? And then the only thing they do is implement, hey, here's a brush that cuts a model in half. They'll never implement a feature that does one thing, ever. For Pixologic, everything ties into everything else. The circular concept was actually the thing that got me hired at Pixologic. When I did a review of ZBrush early on, long time ago, and I was talking about how everything was connected inside of ZBrush. Being able to understand that when the developer does things like they implement a cutting brush, something that's going to cut a model, they are going to tie that into a whole bunch of other features. So you have clip brushes, which I think we're going to look at today. But clip brushes ties into polygroups. For some of you, you won't know what this is, but for others you will. So if you don't know what this is, don't worry. We're going to cover all of this stuff. But polygroups connects to visibility, connects to masking, connects to a whole bunch of things. But if you watch some of the recent Pixologic Z Classroom tutorials, you'll see that polygroups actually is a major feature. It's a very important feature because it's like this selection that stays. It's a permanent selection, a grouping. So it allows me to designate this as a permanently special section that I can do things to. So when they built the clip brush, polygroups at that time was just this little tiny feature. It was basically a throwaway feature. But people barely used polygroups. And in fact, people complained, why do you have polygroups? Why don't you just give me an outliner like Maya? But the dev team didn't want to just implement. Hey, how's my audio, guys? Thomas just said you're getting some audio problems. Good? Sounds fine. Okay. All right, Thomas. Could be bandwidth, either your connection or it could be something that's bridging our connections. But let me know if it continues. Okay. So polygroups has been in ZBrush for a long time. Long time, long before subtools. And like I said, when one of the most common features that people requested in the early days of ZBrush was an outliner like Maya, something where they could put multiple objects in and keep track of everything. But Pixelator refused to do that, and I'll explain why. Today's actually about subtools and what subtools really is. But he refused to do it because he didn't have a complete system. It wasn't just going to put multiple objects in there. He needed to have something that was able to tie everything together. But now, watching the new Z Classroom tutorials, you'll see how tied in polygroups is. So polygroups is down here. This menu has grown exponentially from auto UV and auto groups with UV. This kind of used to be it, and now all of this has been added in there. A lot of stuff, because now polygroups connects in with polish by groups, which is a hard surface feature. Okay, it also connects in here to Dynamesh by group, which is really cool. Okay, and then all these things like ZRemesher has freeze groups. Okay, there's all these things that utilize groups. Edge loops. Before, in early days, it was really just this edge loop feature. Nominally functional. Didn't have a lot of use for most people. People would rather use Z-spheres than this. But then groups loops came. And then from groups loops grew panel loops. And panel loops takes advantage of groups to create amazing hard surface. Anyways, the idea is that a tiny little feature like polygroups might start out innocent. But once they've got the idea, polygroups becomes part of edge loops, it becomes part of subtools, it becomes part of deformation, and he's got this way of tying everything together. So my goal, to kind of wrap that thought up, is to really make sure that you understand how incredibly efficient ZBrush is, and how one feature isn't just a feature, it's actually a system of features. It's a system of elements that are designed to interact with each other. And that's my value to you guys, since I was there during development, and I spent 3+ years, 60 hours a week on this. That's what I can contribute to your life, is how ZBrush thinks. So we got into the basics of sculpting: clay brush, move brush, stuff like that. And we sculpted a head. Well, now it's going to be quite natural that we want to sculpt more. So today's entire class, if it was run by an engineer, we could call this class Mesh Generation 101. Right. Today what we want to talk about is how are we going to work with a model inside of ZBrush in the simplest way possible. Basically, how do we get clay on the armature so that we can start to sculpt, and then how do we adjust that clay or take advantage of the armature, or just basics, fundamentals of getting that clay on the armature. So if I have a head, I'm going to switch over to the move brush. It's set to a hotkey. My hotkey for it is 2. If I wanted to add shoulders to a head that I'd sculpted, I can kind of pull down and pull this back up. And you saw from before that you can kind of Dynamesh this. A little hard to get these both these sides. So I'm going to go into brush, and I'm going to select another brush called inflate. There's a fundamental problem we have here that Dynamesh is designed to take care of. So notice the polygon sizes here. Notice what happens to these as we get down here. They start to become, instead of squares, they start to become diamonds, and also then crazy shapes. So when this starts to happen, this is when you know you're in trouble. So I'm going to talk during this about a subject called topology, But I'm not going to talk about it necessarily in the way that you're used to hearing about it. So a lot of times when people talk about topology, they're talking about animation. Most of the tutorials online, they'll have like a face, then they'll have circles around the eyes, and then they'll show you how to put a circle around the mouth and put the nose in, and how to get the brow and the wrinkles along the side and wrinkles along the side here, and how to kind of piece everything together so that when it animates, excuse me, when it animates, it'll animate correctly. That's what they call animation topology. It's not what we're focused on here. That's something you focus on at the end. It's an end stage. When we first, I'd say up until about a year ago, maybe up until probably about 2-3 years ago, animation topology was really kind of a major concern. But it's not really a concern in the sculpting phase now because we have retopology. Okay, and that's not just ZBrush. That's TopoGun and other things. There's also ZRemesher and whatnot. So nowadays, if you need animation topology, the usual workflow is sculpt, retopologize. So we don't need to talk about any of that. That's all irrelevant. What we need to talk about is the other types of topology. And the only word I've got for it is, let's just call it sculpting topology. These diamonds are painful. They will not sculpt well. These diamonds are a very bad thing. In general, when we are sculpting, we want the entire model to be the exact same size square. So we want the exact same size, same orientation square everywhere, with some edge loops for the arms to help us move things around, but still the same size square flowing through its axes. That's sculpting topology, and that's the focus of the feature set. That's what they're designed to kind of do. So if we come in here, geometry, we go into Dynamesh, and we Dynamesh this. I'm not going to freeze it. And if I zoom in, you'll see that's what it's doing. I'll give it a second for that to propagate to everybody. But you can see same size. And then it's got this little line. This is not animation friendly. Look at these triangles. That's not really what you want animation-wise. But let me show you real quick why you don't need to be concerned about that. Let's just go down to this button here, ZRemesher, and click it. I'm going to stop talking for a sec. Takes a moment. Screen might freeze. Okay. This is not the best animation topology. This is bad. But we did this out of the gate. And it helped create an edge loop around there. You know, could use some more help to define things in that direction. But nowadays, with features like ZRemesher, you have a lot more latitude, is what I would say, in the sculpting topology. Sculpting topology is better with with squares, just simple squares. Let's go back into Dynamesh. I'm going to undo that, and I'm going to lower my Dynamesh resolution to 32. Okay, and you can see what it's doing. This is what you want. You want something simple like this. A lot of people wonder how far, what do I set resolution to? And so this is a bit of a debate in the industry, and I'll set it up for you. So there are the low poly sculptors. Okay, these are guys like Zach Petrock. In fact, Zach Petrock is really the lead proponent of this. You might not have heard a lot about him now. He's got a kid. He's in Disney. He's like a lead there, head. So he's just making his money, saving up to put his kid through Harvard, and living his life. But in the early days, you heard a lot about Zach from his DVDs, and he was one of the main proponents of digital sculpting in the very early days. An amazing sculptor. So you'll see it in his training stuff. I think, actually, no, I know he's got training stuff on his site as well. So then you've got those, and then you've got really high polygon sculptors. Okay, a low polygon sculptor. Actually, before we go into what they are, let's go into who. So here, Mike DeFeo. He's not necessarily the highest, but he fits this category. If you look at Cesar Zambelli, has a female figure sculpting class with us. He works pretty high res. So the low res sculptors really use subdiv levels. The high polygon guys, barely, minimal. Okay, they don't really care about subdivision levels. The high polygon sculptors do. The low polygon sculptors, they care about it a lot. And they have learned to use the technology to their advantage. But we need to kind of set these guys up in context so that you can understand the tool set and where Pixologic is going. And I'll tell you, the caveat to that is high polygon sculpting is where ZBrush is going. The low polygon sculpting, that's basically hair bands. That's the 80s. Ripped jeans, high tops. That's my low polygon days. I don't know what your low polygon days are. But low polygon was designed to deal with limitations of the software or the hardware of its time. In fact, it was designed to deal with the limitations of hardware, not software. ZBrush was very advanced software. It was dealing with hardware limitations. How much RAM, right? How much RAM can I access? What can I do with that RAM? Okay, as well as the processor speed. So you'll see things inside of ZBrush that are still remnants of that past. So, for example, processor speeds. In today's computers, the processors and the software are all taking advantage of 64-bit processing, 64-bit technology and number crunching. So you've seen a lot of, in fact, it's not 64-bit. Let's write what that is. Most software, all software back in the day was all 32-bit. And that's because it was quicker to do math in 32-bit. And you have to keep in mind that ZBrush is doing math at the staggering rate of 60 frames per second. You were literally in a real-time game when you're in ZBrush. It's a real-time sculpting game that is going faster than any game goes right now. 60 frames a second, pulling polygons around faster than any other application out there. Doing that with 32-bit technology. In the olden days, it had to use 32-bit because it was trying to go as fast as possible. That's an old limitation. It does not need to be 32-bit anymore. Now it could be 64-bit. But just like all software, you know, they're built of all these interdependent libraries of features. So if ZBrush was to go from 32-bit to 64-bit, they have to update, you know, hundreds of libraries and hundreds of lines of code inside the software to start to do that. So it's going to happen, but it's going to take a long time because inefficient software doesn't sell. Software with some badass features, that sells. So they got to focus on badass features and make it more efficient over time. Remember, they've got the 1,000-pound gorilla right behind him. So high polygon sculpting is where ZBrush is going. And if you're ever in doubt of that, just ask yourself this one question. If computers were infinitesimally powerful, like if a computer could do anything and everything all at the same time, would you really worry about topology? Like, would you wake up in the morning and say, hey, today's a good day. I get to do UVs and lay out that topology. That's fantastic. I wouldn't. I don't think you're going to wake up happy and excited that you get to lay out topology. It's fun, you know, if you can get into the mindset and there's a cool workflow to it. But it is a necessary task that comes from the limitations of our day. And once the singularity happens and computers overtake the human processing ability, which according to Ray Kurzweiler should be in, I think, 16 years. Somebody correct me if I'm wrong. As of this video, 14, 30, yeah, it should be around 16. Oh my God, it's 6 years, Jason? That's a little fast. Are you sure? I thought it was a little, that's troublesome. All right, well, in 6 years, guys, don't worry, it's not a problem. Topology isn't going to be a problem because the computer is going to be smarter than you are, and so as long as you still, you know, have some sort of control over it, it will do the topology for you. Otherwise, you're going to be doing the topology for it. Just something to think about. It's not the Matrix. They're just going to rope us into topology and UV bots so they can create their own artwork. All right, Jason, 2045. Good. That's what I thought. I thought we had at least some years on us. All right, anyways, let's get back. So now high polygon sculpting is where ZBrush is going. It's a more next-gen kind of thing. It also opens them up to a lot of really cool features. Low polygon they will always support. So what you'll see is they'll introduce features that are geared towards high polygon, and then they will backwards engineer those so that they work with subdivision levels. So you'll notice if you do certain things inside of the edge loop, like panel loops and things like that, when it was first introduced, it didn't work with subdiv levels, anything like that. You know, at least not that I remember. But anyways, the first line of code's not written for subdiv levels. And so you'll be asked to delete them, freeze them. That's why that feature is there. This is a way to keep subdiv levels, but then also keep ZBrush focused on high sculpting tools. Just a little bit of their efficiency. Pretty cool. Anyways, let's get into some stuff. So I rambled a little bit today. We can build the way we have built this, which is you just pull things out. But what I want to show you today is a workflow. You'll see Mike DeFeo do this. It has a lot of advantages, but it's the maquette sculpting process. So you might have seen some tutorials by me on that. I think I've got several out there, and I'm going to show you now the basic one right now. So how you create a basic figure. In fact, let me make sure I'm writing this down so I don't forget exactly what I want you guys to, what I want to cover with you. So we are going to cover maquette. Okay. We're going to cover basic, and then we're going to start getting more advanced by going into subtools, learning about groups. I think that's on our list of things to deal with today. Oops. One second, checking something on the system. It might be good to get some reference in, right? Show you how to deal with reference, some brushes, things of that nature. But I would really like to get you moving onto subtools. So we're going to go over basics, we're going to go over advanced stuff, subtools, and polygroups. That's what I really want to focus on with you guys right now. So this workflow of pulling things out isn't going to work for us long term, but I want to finish this by showing you guys a couple of just the cool things you can do. So we're not quite in a maquette workflow, but I am going to go into the brush and I'm going to go into snake hook. Grab the sides of this guy. Snake hook can be pretty good for form. I'm going to turn the polyframe off. I'm going to go into the inflate brush. So I press B for the brush pop-up, I for the eye brushes, and N for inflate. Okay. And then since Dynamesh is already active here, all I got to do is press Control, click and drag. Smooth out, Control, click and drag. Right? So that's one way that I can build a model and start to get things flowing. This is one way to get clay on an armature. But as I was discovering yesterday, and I was painting, the way that you approach things, your workflow, your process is not insignificant. So if I go into this with this model right now, I've got several things I need to start to correct. And if my workflow, if I'm used to this, if it's my normal workflow to handle it, then it's fine. But this is a workflow that creates a bunch of problems. One of them is I need to now manually adjust the shoulders. So I'm going to have to hold inside my brain, where's the neck, clavicle, where's that kind of come out, and then I got to remember how did things turn, and where's this stuff flowing, how is this working, and then I got to mentally hold form in my mind and start to build all of this stuff mentally first, and then later I put it in. If you're Steve Lord, no problem, right? This is like child's play. You knew where the clavicle was before you were born, so no problem. But when we are creating figures and trying to figure them out and design them and whatnot, this is a messy approach. So it's got some function, but it's messy. So let's come in here. I'm going to go into Lightbox, default sphere. I'm not going to save those changes. I'm going to turn polyframe off. And I'm going to use one brush quite a bit. I'm going to use the insert sphere brush right there. The insert sphere brush is going to be the kind of the thing that we use a lot. This is kind of the key. You can use all of these stuff, like you can use a cylinder, you can use where are they? You can use a cube, you can use cylinder, all that stuff, a ring, but really at the end of the day it doesn't really matter all that much. So I'm going to do a little bit of sculpting, get kind of a basic shape, and flatten the front of the face a little bit. Pull the large point to the side. Also remember, I'm going to come into draw and I'm going to set this closer to 25 or 50. Mike is in my mind right now, so I'm creating more of a cartoony kind of shape from the webinar that we just recently did. Great webinar. Okay, basic simple shape. I'm going to come back in here, insert sphere, which if you notice I have mapped to the number 1. So number 1 key, hotkey. And I'm just going to come into the bottom. I'm going to wait until these two, I'm not going to go here. Well, notice it's giving me a warning saying there's sub D levels. So I'm just going to delete lower. But I'm not going to go here. I'm going to wait until they snap. So I'm looking at it from below. Snap, pull it out. That's going to be roughly the width of the neck. Switch over to the move brush. See if I can start to get some suggestion in there. Now, one part of this is masked, one part is not, and that's just default functioning. So let's make sure you understand masks, for those of you who are newish to it. Number one is it's important to know that you can have a mask on and not know it. And all a mask is it's something that prevents that part of the model from being affected. It's masked off. This is like watercolor masking or airbrush masking or anything like that. It's just masked off. So if you're ever trying to get this and you can't, it's not working, first you come over here and make sure view mask is on, then you check subtools. But view mask is on. You can clear a mask. I'm going to undo that. You can invert a mask. You can just mask all. You can blur it, you can sharpen it, you can grow it, and you can shrink it. But what we want to do right now is just invert it or control click, because I want to adjust the head a little bit. Get that a little differently sized. Okay, and then I don't care about the mask anymore. I just go back into my insert sphere brush. Look at this guy from a back, wait until these two lines connect, and then drag out some other shape. Switch over to move. Okay, and I just got a bunch of these spheres. This is all it is. Sphere, sphere, sphere. It's clay that goes on the armature. And then you adjust. That's it. So let's put a midsection in there. Oops. Switch over to the move brush. Okay, boom, boom. Throw some hips in there. But now, you know, am I in line with this model? Did I screw something up? I haven't been keeping track of size or anything right now. So how do I know this is adhering to any proportional standard and I haven't kind of completely lost the plot? I'm going to control, click, and drag to just remove the mask, and then I can treat it all as one piece. Okay. Let's talk a little bit right now about once you've got kind of a form in place, how do we start to kind of, make sure we're proportionally correct? Norman's asking a good question. How is this workflow different than Z-spheres? And the first really significant difference is that these are actually polygons. A Z-sphere is not. It's an intermediary system. So in a Z-sphere, you do something, and then ZBrush will extrapolate between that to say, okay, you meant there to be like an arm or a cylinder there. But there is some differences between when you place a Z-sphere and the results that you get. In this maquette workflow, this is what I get. There's no difference. I'm putting something, moving it, that's it. Rachel's asking I'm about the error message, composed multiple subdivision levels. Delete your subdivs levels. So if you get that error message, you come up to geometry and you say delete lower, and if possible delete higher. Basically delete all. Now if you're working on a model that you've been working on before, you got to be careful of stuff like this, but if you're following along with me, just delete it. That's it. We don't really care. We're not low polygon, we're not high polygon sculptors. We're just trying to sculpt. That's it. Okay, if I turn polyframe on, you see all of these are separate groups. They're all separate spheres. But what we want to talk about right now is how do we get a sense of proportion and measurement, which is really important when you're dealing with the sculpt. I could have accidentally made all of this stuff much smaller, looked at them and been like, oh, that's not what I wanted. So let me talk to you about the floor, possibly the grid, although the grid is covered in the lectures that you get, and it's covered pretty well. What I want to do is really just focus on, if you're on the fly, how are you dealing with measurements? And that's the floor. So notice that you have this gridded structure, and it is below the model. Also notice that if you change the position of your model, right now there's a gap. As soon as I click, that gap is closed. So this floor is designed to auto snap to the bottom of your model. Wherever that model is, it's designed to snap to that. And then also notice inside this floor, if I was to blow that up, notice that you have a X, Y, Z button, and notice that Y is active. You know it's active because it's very lightly gray and you can barely see it. The other ones you just can't see, so they're not there. But you have to trust me. If you click, then it will happen. So in this particular case, I need a grid behind the model to help me understand, you know, how the proportions are working out. And so in that case, I'm going to say click X. X didn't work. I'm going to click X again, and I'm going to go over here and click Z, and Z worked. And that's what you do. Over time, you don't guess. You know exactly which one it is, but you know, it's 5 seconds. Just click X, click Z until you get it. But notice that I have this gap. And notice that this is right behind the model and, you know, all that stuff. We're going to come into Draw. We're going to go to this elevation that says -1. This is a really important feature. So if you're not watching, you wanna watch this. You go to Draw, ELV, and you set this to 0. Now notice as I do that, the grid changes. Instead of being at the bottom, it's now in the middle, and boom. Now it's in the middle of his head, which, if you remember correctly, is the middle of the sphere we started with. So everything is now at what you would call a world origin. If you're a Maya, Max, or former XS, I just totally lost my brain there, XSI guy, then you'll know it as the world origin of some sort. And technically speaking, this is an accurate placement for world origin. If you're bringing it into Maya, it would be roughly in this place. There are some variants. If you come into geometry and you see position, you'll see there's things like Y and Z, and then there's the size variant. These are all things we'll discuss later. But when you're in ZBrush, you have to remember one thing. You're not in Kansas anymore. This is not a world space, real world 3D unit. This is, everything's in ZBrush speak. And ZBrush had to do that in the early days because they had to control the entire operation to be able to do what ZBrush does. You would be amazed at how much ZBrush is custom coded and how much of your operating system it takes over. It's not insignificant. You know, everything from memory management routines to other aspects. ZBrush kind of handles a lot of that itself. It's pretty awesome. But anyways, now that's probably less relevant. They could have coded in real world units, but back then they couldn't, and so that's our legacy. All right, so the grid's not quite working for me, and I really need to turn Y off because I just need to see a background grid. So I need to come into Draw, and I need to adjust the grid size and tiles. So I just want to grab this. Let's just set this up to 8. And now I would love it if I could get a tile to be roughly the size of a head. It looks like I'm not quite there. So I'm going to come into tiles and see if I can increase. So that made it smaller, or decrease. So I decreased it to 5, and I'm just taking my cursor and, you know, guessing. 4. So it's somewhere between 4 and 5. And I'm just using this right now for very loose measurement systems. So I'm going to put it up at 5. And then I need to move the entire thing up. So I'm doing a little trick right now. I'm using the move brush, but I've taken the draw size from 62 all the way up to as high as it can possibly go. If you go as high as it can go, then you're not going to get a lot of the distortion that can kind of happen. Like if you're working lower and you start to move it and then his head starts to squash. Instead, we're going to go all the way up, and I'm just going to position it. And there should be minimal loss of form. And just for the heck of it, I like to make that the center line. So I'm going to move that until it's like right where the pubic symphysis would be. Okay. So this is, as a sculptor, a way in which I would use real basic measurements inside of ZBrush. And Jeremy, focal shift, yeah, that can make a difference in using the move brush, and you say hit your focal shift all the way down. But, and I don't know what they've done with this feature, but they used to be a feature. If the brush size was all the way at the maximum size, then it would treat it as this move function instead of, you know, there would be no fall off at all whatsoever. You would literally be able to, in fact, let's just turn symmetry off and test this. Oh yeah, it's only able to move increments. And that feature's a little bit off now. A little bit off. So let's not depend on that. Looks like they changed some of that code. But for now, this is a quick, easy way. All right, so I've got this. Now I'm going to come in with my insert sphere. I'm going to add a shoulder, and you know, my teacher algorithm taught me shoulders were cubes, basically. So I flatten this out on all sides. Notice how I just turned a sphere into a cube, and I'm going to pull it back. And notice also I have turned symmetry off. Accidentally left symmetry off. And if you ever want to know, cool trick with understanding shoulders, anatomically speaking, they're in the last half. If they're moving forward, then you start to get into, it starts to become a problem. Hunchback or bad posture or things like that. Also, you want the scapula to, you know, follow the rib cage. So it's got to move a little bit like that. I'm going to press Alt with the move brush, and that moves it out along the normal. And that's helping me kind of, without having to inflate, I just kind of push that in. And pull it out. And I'm going to go all the way to creating a hand here before I worry about symmetry. Insert sphere, roughly the width. And then if you want to take a sphere like this and pull it out, it's not as simple as stretch, stretch, because that happens. But it is as simple as stretch, stretch back, stretch, stretch back. It's a two-step. Boom, 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 boom. End of story. Okay, B-I-N-G-O for the inflate brush. And if you have kids in the car, now I'm going to press Control, click to invert, and that shoulder just got kind of crazy. And pull it down a little bit. Control, click, and drag to clear. And we need to put an elbow in, which I would not begrudge you treating as a separate piece, because the elbow has this olecron process. So it's this big, huge thing from the ulna. Tricep connects to it, you know, in multiple places. And it's just real powerful, real meaty thing. That's your ulna. Okay, and boom. Move brush. And that is a really massive forearm, so I need to kind of up that. Ridge muscles. Do, 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 do. Flexors. Okay. So we've got a little bit of a form that we've worked on. I don't need to kind of keep doing this too terribly much. But I am going to show you right now how we can kind of mirror this now. Now that we've kind of screwed up, you know, we want to mirror it. So I'd look right now in a thing called Modify Topology. There's a whole bunch of stuff in here. Pretty cool. One of them is Mirror and Weld. What it'll do, mirror from this side over to this side. Which isn't what we wanted, right? Because we're like, well, that's not a mirror and weld. Technically, that's a destroy what I just did and weld. So it's a two-step here as well. We need to move these. So we got to take this side, put it over onto this side, and then we use mirror and weld, and that'll put it onto this side. So we go into deformation, and we say mirror. Again, if you're not watching, you want to see this because I'm going into several menus here. So I went into deformation and mirror, and now I'm going to go back into geometry. I'm going to go into modify, mirror and weld. And there you go. So mirror and weld, you need to know, will only come from one side to the other. It does not have any sort of AI that figures kind of anything out. Okay, now I want to get into a bit more with this, but first let's make sure symmetry's on. So I pressed X. I'm going to do some kind of adjust the look of the character a bit. And then I need to get into some more advanced stuff with the face. But before I move to the next step, let me actually talk to you guys. Let me see how we're doing here. Okay, any questions on what I've got so far? I got some long questions. Rachel, okay, we solved that one. Okay. Chris, I'm pretty sure they, this red and blue are the X, Y, and Z now. They're the indicators. So those little guys, they put it there. Mm-hmm. Okay, any questions for me, guys? Anything else? How are you doing? Carlos, when is it good to use QRemesher? Well, QRemesher has now been called ZRemesher, and it's an end. It's largely an end stage, but sometimes it gives you better topology than Dynamesh. And if you're a low polygon sculptor, then ZRemesh is something you might do early on so that you get good topology or better topology than Dynamesh. But in this case, since we're sculpting, I really only want you to think about Dynamesh. And I have not Dynameshed this model yet. Preacher, do you work with perspective on? And when you do screen grab, should perspective always be on? Perspective, I think I talked about this a little bit last time, but perspective is a choice. And everybody chooses differently. But so actually, I can't say which one you could use because I know some sculptors like Steve Lord will often sculpt without perspective on. I sculpt with it on all the time, but then I see problems in my sculpts when they're 3D printed that result from the false perspective, or at least from the gap between the computer and reality. So it's a plus minus, you know, it's something you have to experiment with. Jason, how do I turn off snapshot to grid? What do you mean by snapshot to grid? And turn it off. Did you get ahead and snap some and put something on there? Let me think for 1 second. Where is? How are they doing that? Let's do it right now. Actually, let me finish looking and then I'll come back to that one. Jacob, this is all still one subtool, and we're only using polygroups. In fact, we're going to use polygroups right now. Gabriel, can you just quickly repeat the correct proportions? Well, I'm doing a character here. A lot of times I do real world, but if you use an 8-head character, then, you know, the head is 8 or 7.5. 8 is the easiest, though. Okay, Jason, a little quick troubleshooting for you. You've snapshot to grid, so let me just come in here. You've done something like snapshot to the grid. And let's turn our elevation back to -1, or yeah, -1. So now you've got something that looks like this, Jason. Am I right? It's kind of a cool little feature. So it's storing the grid in these views. So you just kind of select texture off, texture off. This is the manual way just to always just go in there and make that happen. You're going to always just turn the floor off too. But anyways, that'll get rid of those and allow you to continue to use the features. Oh, we want Z and not Y. And we want fill mode differently. We want fill mode set to 0. Does that help? Oh, and I lost all my settings. I think we had this set to 8 and we had the tile set to 5. Okay. Alrighty, now let's move on. So we have a basic maquette process. And really this is just insert sphere, plus move. That's it. But now we need to know how do we do things like, let's say take this rib cage and I need to move it in. I want that rib cage to be thinner. Maybe I want to add parts, like I'm going to add a character's breasts or something like that. I want to be able to adjust parts of this model independently. This is where we use subtools. Or not subtools. This is where we use polygroups. So polygroups right now is designed to kind of take care of this. To make it really clear, let's start to add some features. Like let's add a little nose like Michael does. So he'll add in a little piece of clay, switch over to the move brush, and he will start to define this nose. Control click, we can start to do some of the sculpting. Notice how it's not affecting the nose. We want big cheeks. In the eyes, I can use move and press Alt, and it moves along the normals. It's a really nice way to handle things. Okay, cartoon character, so not a lot in the lower mouth area. Control, click and drag, and I'm going to move the nose down. Control, click and drag, and there we go. Now undo, and I need to really move that back. That whole area is going to need a little bit of touch-up. Long neck, right? So I got all these parts I need to move. So we need to talk about, one, how do I adjust the chest? And then how do I adjust the head, nose as one piece so that I can move these guys down? So that's what we want to talk about right now, is how do you select polygroups as part of your process. Right now we've just used masks in the default, but now I need to do some specific editing. Oh, Damon, that's still there. Okay. Thanks. Let's see. Let me, yeah. All right. So now this part, we're going to turn polyframe on. Now we want to select just this chest. One way we can do that is we press Control, Shift, and we click and move that in. Control, Shift, and there you go. But you can't see it when you're doing it, so it's a bit of a problem. So let's undo that. Another way we can do this is we go to Move, we press Control, and we click from one to the other. So we pressed Control, we clicked here, and we dragged to here. Now we've created a mask that we can use, and that really is just quite simple to kind of help us build form. So that's real easy if all we're doing is moving one piece. We just go into Move, Control click, go back into Draw, and there you go, right? But now we need to move these two pieces. How are we going to do that? Because if we go into Move, well, the nose is hidden too, or masked as well. So now I need to show you guys a couple of tricks. This is the selection process. If you are already familiar with ZBrush, you already know this, and this is going to be a little slow for you. If you don't know ZBrush, what I'm going to show you right now is crazy important for you to watch, because it's all hotkeys. It's all inside the canvas. There's no feature for it. There's no easy way to do it. So what we do is we hide the head. So we're going to now talk about visibility. We're going to Control-Shift-Click on the head. So again, we Control plus Shift plus click. And that hid everything but the head. Now we're going to Control-Shift-Click and drag, and that inverts it. And then we're going to Control-Shift-Click, and that hides it. So the first thing we did was Control plus Shift plus click. Okay, that hid basically everything else. Okay, then we Control plus Shift plus click plus drag. That inverted. And then we Control plus Shift plus click. And then that hid. So the same action, Control-Shift-Click, does two different things depending on what's happening in the interface. And this is, again, part of ZBrush's drive to optimize your behavior and try to make things as natural as possible. In the process of making them natural, you know, it sometimes is not natural for those who are used to incredibly unnatural interfaces like Maya or something like that, which is a beautiful program, but I don't think anybody would ever say that Maya was very natural. I don't think I've ever heard that. It took me 3 months of solid, full-time learning before I felt like Maya was natural. ZBrush should take like a weekend before it starts to feel natural. Even if it took 2 weekends, that's not 3 months. So this is part of the drive. Control-Shift does two different things. This will always invert. And so that's what we need to do right now. We need to invert. So I want somebody to type it out. What am I going to do if I want to invert? I'm leaving it up on the screen. This is crib notes plus 10. Control-Shift-Click and drag. Yes. So Control-Shift-Click and drag. And voila, it inverted. So what am I going to do now? Because I have a piece here, and I've got a piece that's hidden, and I want to be able to affect this piece. I want to move it down. So what do I do now? Because if I just Control-Shift-Click, it's going to undo everything. Now I need to do something. What am I going to do? Mask. So you can go into masking and you can just say mask all, and that will only mask what was visible. So mask all works. You can Control, click, and drag. That's another process. You can Control, click. So there's two things. There's Control plus click and drag, right? There's also just Control plus click outside. That's it. Those are the options. Or you go over here and you say mask all. Those are the three options that we have. So then we can Control-Shift-Click to show everything. So again, to show everything, we do what? Control plus, how do I show everything? Yeah, Just click. Control Shift. And then now I need to invert this mask. So anybody want to take a guess? We know that Control plus click was mask all. So what would an invert mask be? Remember, you got to think like an alien species that is thinking on multiple levels and multiple dimensions. Control click. The same feature doing two different things. So control click, if nothing is masked, will mask it all. Control click, if something is masked, will invert. I just wanted to spend some extra time there because this is both the quirkiness of ZBrush and, like with all quirky people and things, it is also the genius of ZBrush. Jason is asking, how do you blur? It's just right here, blur mask. Or you control click on the model. Now in this case I don't have any borders, so that doesn't help. Control click. All right. So now we've got this real simple process where, we're going real slow, we're just doing things, learning as we go, and I'm talking quite a bit. But now what we want to do is, instead of using the move brush, we want to look at the next possible feature, the next cool thing that we could do. So there was the move brush. This has been in ZBrush since the beginning. Very powerful, very useful. But there's got to be other ways to, like, let's say, take a gun on the side and move it out here, or move it into the front, or something like that. So this is where we come up with a feature called transpose. Anybody, and Mark, I'm talking to you, want to explain what transpose is? Because when I was first introduced to this transpose, it's a cool story. I think it's a cool story. You might think it's lame. But anyways, transpose came in one of my daily versions of ZBrush to kind of test when I was working there. It's just I come into the office and, there's this new thing called transpose, and I'm like, what the hell is transpose? And what does that even mean? Right? I know what it means now, so it's kind of old hat, but just it's 100% a feature an engineer would name. Mark, I love that. So anybody want to gather, what does transpose mean? Because it's actually named after, the definition. I mean, it's named after what the program is doing, and so that way it's actually kind of a cool little note so that you know what's happening. You can, as Stefan says, it's transforming and positioning, but Norman has the technical definition in there. Transposing a matrix, a matrices, a matrix. So what it's doing is it's just taking like one group of numbers and putting them in another box with groups of numbers. What could be numbers in ZBrush? What kind of numbers is it dealing with? Yeah, exactly. Robert's got it. X, Y, Z. Every single polygon in ZBrush, and in every program, has an X, Y, and Z. In ZBrush, every polygon, or let's say actually, the correct way to say it is every vertice in ZBrush is X, Y, Z plus RGB. Plus, if you want, an alpha channel for transparency. there is an alpha channel for a vertice, but it's not part of the default math. It has to be applied through a material, and if I remember right, it's applied through best preview render, so it's outside of the normal run. So for every single vertice, I want to just step into a little bit of math here. For every single vertice that gets moved in real time, again at 60 frames per second, ZBrush is calculating mathematically everything it needs to do for both the X, the Y, the Z, the R, the G, the B. That's 6 units of information that it has to calculate, you know, plus a lot more stuff. But basically it has to calculate that every time you put your brush on and you move something. It's quite a bit to kind of contemplate. It's also why ZBrush doesn't do textures. This is a little tidbit. But what would textures do? If you had a texture map on a ZBrush, what would that do to this calculation? It adds 2 variables to what every single vertice needs to do, which is U and V. This is technical, so if you're not following along with this, don't worry, just let this kind of slide by you. But if you're on the technical side and that's kind of how you teach, this is just kind of a cool little thing to know, but it's not essential. I'm just telling you some of the math and how ZBrush thinks. So by default, every application has to deal with X, Y, Z for a vertice. ZBrush adds poly painting, RGB, because there are some cool things it gets from that. If it was to add texture map, it would have to add the U and V to every single operation. So if you have 6 units and you're going to add 30% more on top of that, that's not an insignificant thing. It's for every vertice. So one of the reasons why ZBrush doesn't do texture maps directly on the models is because that slows things down. It slows the calculation down. It may eventually do regular texturing, as Mitchell was concerned about. It may eventually do quote-unquote regular UVs, texture mapping. But again, you got to look historically. Texture mapping was a limitation. It was a process that overcame a limitation, and even today it's used to overcome limitations. In the real world, if I got a sculpt in front of me, I don't use a texture map and apply it to my real world sculpt. That would be crazy, right? To be like, okay, here's my clay sculpt. Now I'm going to go over here to this 2D drawing or painting in canvas. I'm going to paint the canvas so that it looks good on my clay sculpt. I don't know about you, but that sounds weird to me. But we do that in the computer with what we call regular texture mapping. And there's a workflow that we learn for it, and there's a process, so we're invested in it. I know the workflow as well. I'm invested in it, and it has massive advantage given the environment that we're in. But if you had unlimited polygons, would you do UV layout and texture mapping? Or would you paint directly on the model? And if you were Pixologic and you had the choice, do I implement a UV paint system, or do I change the world by making UVs irrelevant? Which one would you choose? These are some scrappy people over there at Pixologic. So you guys know what they would choose. So anyways, transpose is literally taking from that mathematical term, transposing matrices, which, you know, has a lot to do with, say, rotate, things like that. All technical, just a little tidbit, but it takes you into some of the I don't know, some of the ways in which, so I don't know how to say it, except for it's some of the problems that Pixologic is trying to address. So transpose, it's named after that because that's the mathematical term. And what we are going to do right now is transpose or translate the position of the head and nose. I'm going to press Shift and move down. When I draw out, I'm pressing Shift and I'm selecting the center white dot, not the other ones. This one's really cool. We're going to use this here in a second. I'm selecting the white one and moving that down while pressing Shift. And I'll move that back a little bit. Cool. Back into draw. All right, and now I want to show you a couple of cool tricks. Cool little neat ways to do it. And they rely on us using move, scale, and rotate. Really, they just rely on us using move. So the first thing we're going to do is we're going to insert a sphere for the eye. Look at it from a side view. I'm going to go into move, and I'm going to select that center white dot, press Shift, and move it in until it fits where I want it to fit. There's some sculpting I need to do here. Maybe on the eye, the brow. So I'm going to Control click to invert. Oops, switch over to move. Okay. Control click. Those eyes are quite far apart. So move, drag out my line. I drag it off the model. Remember, off the model. The reason why is if you drag it off, then it'll be a straight line. If you don't, it will snap to wherever that next polygon point is. And that's going to be a problem. So, drag it out, drag it. These are technically speaking these are, how do I say it? I'm going to go back into move, Control click. These are temporary bones. That's the way people like to phrase it. Oops. Scale. In scale, I don't select the center one, I select this guy, the outside one. I also have to be mindful that scaling functions differently whether I have local symmetry or not. Okay, there we go. Control click. I have a little bit of eyes in there, and now we're about to get into an eyelid, but I want to kind of stop because the eyelid is a really significant point. So I see a whole bunch of comments. Let me just address things before I jump into something more technical. Okay, cool. Just some notes on our previous discussion. All right. All right. Okay. All right. So now, now I'm going to address the sculptor in you. The sculptor in you needs to know how to create form without having to understand every single nuance of anatomy. And so what I'm going to do right now is I'm going to give you an anatomy lesson, hopefully to provide a little bit of a distaste for it. So, the eye, oh my God, so many things that we have to think about when we sculpt an eye. So I'm just going to draw them real quick. One of them, the infraorbital margin, which is, you know, a really nice Latinate way of saying, hey, that's the bottom of the orbit of the eye. That's where the bone is, you know, is now the now facing forward. There's the supraorbital margin. There's the frontocephaloidal process of the maxilla, this little guy that goes from the maxilla up. And then there's the lacrimal bone, which kind of helps define the inside. And then there's the glabella, which does this kind of beautiful conch shell. And then there's the superciliary arch. And then there's the external angle, the temporal line. And that's just the beginning of that. Because on top of that, there is also this fat underneath the eyebrow. And then there's this thing called the palpebral ligament. And the palpebral ligament has an upper and a lower portion, and the portions connect on the inside of the frontal cephaloidal process. But did you know that the palpebral ligament connects on the inside, not the outside? Were you thinking about that yourself when you sculpted? Did you even want to know that? At a certain point, you want to know that kind of stuff. And what's happening here? Where is the palpebral ligament connecting in there? And does the palpebral ligament connect right at the edge of the eye? Or what's this extra space that exists kind of in here, this thing called the caruncula? All that stuff gets really important. And then how are eye bags created? Well, did you know that there is this attachment point basically here and here and here and here and a couple of other places? These are like bolts, like Frankenstein bolts, where our face is the skin on our face is welded to the bone. It's in these real simple places where the skin is bolted to our bone. If you were to unbolt it, you could pull the face back. And that's what surgeons do when they do a facelift. They make a little insertion here on the side, right by the ear, and they saw through this Velcro stuff, which attaches the skin to the bone, and they saw through this, and they saw through this, and then they pull the face off like a UV map. Seriously, like a UV map. Stretch that UV map out, and then they press it back on. Maybe staple it. But they Velcro it back on, which is freaking nuts that you can literally pull your face off by just sawing through a couple of these Velcro points. And it is literally a UV map of your face. It's really nuts. But that's how a facelift operates. That's some facial anatomy for you. But you don't need to know all that. It's helpful, but it takes a long time to learn it. And one of the things that we want as artists are workflows that make us smarter than we actually are. I know that sounds a little tongue-in-cheek, but it's kind of not a joke. You know, if your artwork, if everything you did was based solely on, you know, on the amount of knowledge you were able to hold and process at any one given time, well, I mean, your brain's not designed to work that way. We have workflows and processes so that it augments us in our artwork, in our business, in everything. You know, in this business, it's all systems that are designed to augment the things that, you know, I really love to see out in the educational world. So we have marketing, we have this. And when I go and I paint, I have a color system, and I'm thinking about forms and form systems. And that's what we're going to talk about right now, form systems. So what you need is an upper eyelid that is surprisingly shaped just like an eyeball. And you need a lower eyelid which is shaped surprisingly like an eyeball. Because remember, the eyelids hug the eyeball. That's their primary function. They hug it. So, and then we can do little tweaks. So we have a process. We're gonna create an upper eyelid, a lower eyelid, then we're gonna do this little tiny tweak where we put a caruncula in, where we make sure that the lacrimal flow is happening, and we make sure that the upper lid is dominant over the lower lid. The lower eyelid tucks in, the upper eyelid overlaps. That'll help us because you'll see a wrinkle that flows out from that upper eyelid in some people. Gets confusing, but we can do it. So how are we going to do that? Because we've just created this eye. I can come in and I can insert another sphere, make it roughly the same size. This is one way. Then I go to move. And then I can just drag this line out. In this case, it doesn't matter if it comes from here to here. But I'm going to take this lower line and I'm going to use it to cut that sphere in half. So let me just move this out to the side. What do we have here? Just a half a sphere. That's all it is. So we'll put it back. I'm going to undo. Look at this from a side, drag out our little line, and put him in there. Get it positioned. Maybe we need to rotate it so that we get a different angle, move, and position it. And then we need to be mindful that the eye is going to be moving in a particular direction. What's the slant that we want on that eye? Maybe we need to scale it. And we don't care about local symmetry. We just scale it and move it, right? Because it's got to be a little bigger so that it can have thickness. And make sure you have thickness. When in doubt, don't look at your own eye, because as sculptors we can't use natural thickness all the time. Look at Bernini. Look at any of these guys. Michelangelo. Look at these portraits. Look at this, how thick this lower eyelid gets. This thickness, as well as the fact that we're looking at it like this, where we can see some of that lid, that means that it's going to get some light, while the bottom part is going to get shadow, which is perfect, because sculptors work with light a little less than painters, but not too much less. Okay, so now how do we do the upper eyelid? And I have to give credit. This is you'll see Mike DeFeo do this. This is his working process. I'm stealing this from his webinar because it is a really great way for you to show it. I think it highlights the ZBrush sculpting workflow really, really, really well. Okay. Now I need to get the upper eyelid. So what am I going to do? Well, I can draw it out again, but I don't really want that because I want the upper eyelid and the lower eyelid to be exactly the same size. I need to duplicate this lower eyelid, and I always forget how, but it looks like I remembered this time. You see now there are two. Let's turn polyframe on. One, two. What I do, you press Control, make sure you're in Move, make sure that everything else is masked, no subdivision levels. You press Control, click the center line, and you move it out. Let's turn perspective off for a moment. And now what we want to do is take this guy, we're just going to flip him around using Rotate. So I'm going to drag out, turn Rotate on, flip it around, move, and I have an upper eyelid. Rotate it because it's not quite mirrored. I mean, you could mirror it if you wanted to really use all the ZBrush features. but this works. Maybe scale that out a little bit. Move it in a touch. That was too much. We don't even need to scale it. That's overkill. I'm just going to use move. And notice that I'm not clicking here, I'm clicking out here and letting just the edge of my brush select it. What time are we at? Good, okay. So we got a couple of cool things. Let me clear the mask. We've got the upper eyelid, we've got it dominant. We can see both the upper and the lower. We can see the lids, which is great. It's going to really help us. And they're both thick, so that's really nice. But now what we need to do is we need to sculpt the inside of the eye now. The eye itself is done, for the most part, because this is following basic sculpting form. We are solid. Now we need to get the other forms around it working. So I'm in draw. I'm going to go into move mode, control, click and drag, because I need to sculpt the face. Back into move, back into draw. And just start to get this area a little bit cleaner. We may need to rotate the eye. I don't know. I'm hoping not, but I don't think so. I think we're just going to try to work with this. And switch over to clay buildup. Invert that. Hit the move. See if we can't put a little bit of space in there for the caruncula. And get that caruncula to attach. Okay, and boom, boom. I feel like I need to open that because you can now adjust the shape of this a bit. What kind of eye? Wide open almond eyes. Move, control, click and drag, draw. Droopy eyes. Okay, now we need to adjust that nose. And then on from there. So, whoops, lost it. So I'm going to press F for frame. Get it back. All right. Now, I'd rather these eyes be infinitely larger, but I think we're going to fit. I'm just going to make them a little bit more appealing without doing any major things, because this is really more about the lesson. Whoops. Okay. Okay. Now you, whoa, what happened to his head? Make a change in one direction. All kinds of things go wrong. All right. So now that's one trick for how we're going to do these eyes. It's a really neat kind of approach, I think. Very, very sculptural. And that's the major advantage here, is that we have a process that allows me to get something with decent results. Now I can go into Dynamesh. I'm going to set this to 64 and turn Dynamesh on. Oh! There you go. Not working, right? So this gets us into a very significant dilemma. Low polygon versus high polygon. If we're going to sculpt our forms like this in the maquette process, we have some cool advantages here, but we have some downsides. We can't use low polygons. We could turn project on and Dynamesh, but even with project, it's not fully functional. It's a bit of a problem. So even with project, we're going to have to deal with some issues and figure these things out, you know, one way or kind of or another. So the solution here is high polygon sculpting. And 128 actually isn't high enough. 200. 300. These are the kinds of numbers that you'll see guys using now. Now that means that my model is now 500,000 polygons. I haven't used subtools, which I was supposed to get to today, but I do have form. Now anywhere that the form was not clearly defined, though, I have this problem of, am I able to smooth things out, and can I get things created, you know, reasonably well? Well, this is where some of the new brushes or some of the brush knowledge becomes kind of relevant. So in this kind of workflow with high polygons, we'll talk about this next week, but you need brushes that are topology independent. You need brushes that are going to work at any subdivision level with triangles, with quads, with whatever. They're just going to function like you expect them to function under any real circumstance. That is the clay brush and all the brushes that are built on the clay brush. If you look at a tutorial, an old school tutorial from Zach Petrock, you'll see a lot of standard brush or Neville Page. So their workflow is standard brush, smooth. Okay, that's the low polygon approach. That's the old approach. The major new approach is clay brush and a bit of a higher resolution, and really not worrying about subdiv levels. You know, up until a certain point, like I might add 3 subdiv levels here, but probably not too much more. You get some sculpting done, and then that's your design sculpt. Then you go and you re-topologize. Let me check in with you guys. How you doing? How's things going? Jose, I'm not sure. We will try to have that class. Okay, so if we recapture what we've done right now, we start to talk. You know, we have a maquette workflow that has used some basic form generation techniques, but it's given us a mesh that we could have taken much further in the base shape. But now we've got, you know, we've got some work to do to kind of clean this up. If you're using this process, a lot of your work is before you Dynamesh. It's getting things positioned correctly. I'm going to use my slider here and go back through my menus. There we go. There we go. Delete those. It's making sure that this stuff is clean and sculpted beforehand. Make sure your proportions are all lined up. Everything's kind of flowing as smoothly as you can kind of make it. You want to get that kind of work done and spend the time. And if you take the class with Mike DeFeo, you'll see, you know, it's a real interesting, old school, solid workflow, like a workflow that will teach you how to sculpt. Mike DeFeo's workflow. One of the best tried and true methods, because he's using the same processes that old school clay guys will use. You know, but here you're worried about little things like this. Stuff that in our CERT program we're not that interested in. You know, I'm not that interested in you being able to sculpt really well. My sculpt is going to only go as far as the lecture material needs. Because sculpting is something you want to give yourself time to do. You don't want to be, you know, rushing it. Give yourself the time, invest in it. And when it's not working, don't worry, because it all takes time. There's a reason why they say, you know, artists, like let's say Odd Nurgem will work on, you know, 6 life-size canvases in a year. You know, or you get Bo Bartlett, you know, how many canvases does he work at a time? 1. You know, when we're learning this stuff, it's a process, and you have to respect that. Can't speed up all of this. At least we can't speed up without having some problems. Okay. I'm looking at notes again. Can I separate one object in polygroups? Yeah, actually, I think that's what we're going to focus on right now, Carlos. Okay, so there's a couple of things. I can explain Dynamesh, and we can talk about subtools. So how would we want to do this? Okay, I'm going to just keep moving with this character, and let's focus on hair. I think hair will kind of set us up. And it'll also give us one extra brush that we can focus on. Here's what I'm trying to do. Since I'm in the CERT program, I get to explain the teaching problem to you guys. So now what I want to do is I want to talk about subtools, but I want to talk about it in a way that kind of showcases the primary reason for subtools. Those of you who were in the CERT program before, I kind of harped on this a lot, but for the new people, what are subtools? So subtools, let's save this model. I'm going to save it. Move that off to the side. I'll call this delete. Okay. Let's take a look at a model that'll explain subtools, or a project. So here's a project. It's inside of ZBrush. Everybody can see it. This will explain subtools. So you've got the body, the eyes, the teeth, you've got the kimono, some laces, a belt, shoes. These are all separate subtools. And what that means is that if I'm in one, I'm not affecting the other. So I'm in the move brush, I'm pulling the body out, but that's not affecting the boots or the pants. In order to affect the boots, I got to select the boots here. In order to affect the pants, I got to select the kimono, and then I'm no longer affecting anything else. So this allows you to have multiple objects. That's what we used to, the old term. And then you have to go into that other subtool to undo and undo. So I got to keep going into each one of them to undo this behavior. But this allows you to have multiple objects, such as clothing on a model, which somebody would want. They want to find a way to put clothing on a model. But who here remembers what's the primary reason for subtools? Roberto remembers. Renato? Yeah. Right, Mark. Okay. It's your polygon count. If it wasn't for this one feature, I can guarantee you ZBrush or Pixologic would not have made the eyes a separate subtool. They would not have allowed the teeth to be a separate object. They would have used what? What's the other feature that they would have used? We were just looking at it. Not layers, polygroups. So in a lot of ways, what I'm trying to present to you guys is there is a built-in dichotomy, a built-in rivalry between polygroups and subtools. Polygroups is the old school, subtools is new and has some major enhancements. In general, you want to keep everything as one object because it just makes sculpting so fast and so easy. But you can't do that sometimes because, for example, if you've got a kimono where you need to have a pattern on it, like this is almost 1 million polygons, 968,000, yeah. So that kimono alone, let's turn the texturing off. I'm going to turn that paintbrush off, and I'm going to turn polyframe on. And let me just sculpt so it'll zoom in there. It's quite dense. If I go down the subdivision levels, higher, 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 higher. There you go. That'll give you a sense of how dense it is. If you're going to be putting a pattern, such as that texture that you saw, whether you're painting it or putting it in geometry, in this particular case, it's painted, you have to have more polygons. Okay, so let's talk about the polygon matrix. You'll see this in the lessons, but we need to know kind of how do I say that? Let's just call it the polygon output. How many polygons does your model need to be? Jason, what's a next-gen game character now? Polygon count. Let's assume it's a hero character and it's a high-profile franchise. So they want really good resolution. And let's say, like in Jason, if you can tell me what would be the polygon count in the face and the whole body. So how many polygons your model is depends on, is it for games? And if it's games, is it in-game or cinematic? Is it for film? Is it to be 3D printed? Jason's, yes, so games kind of vary all over. Anybody want to tell me what they think a next-gen game character is going to have? How many polygons? In-game. Joaquim's saying 80,000. Wii and Xbox One, yeah, the Wii's got to be low. So Anthony saying 1 or 2 million. In-game, though, and animating. That's the thing. Remember, it has to be animating. And that's the real big problem, is how do you get an in-game model to animate in-game when the game has to run 30 frames a second, right around there, and move in a realistic fashion, because you need polygons for it to render, right? So in-game, let's just say there's a face. God, I can't remember, but let's just say I'm going to set this at 15,000. Put in the discussion boards, guys, any links you've got to stuff. And Aaron's saying, games now are at 60 frames a second. Okay, good. Jason, 1 million polys per character for Uncharted, and that's the one Rich Diamond was on. So Jason's saying Uncharted 4, 1 million polys per character. I remember Rich saying that the face alone was like 15,000 polygons. Pretty crazy. This is like the in-game model is 15,000, or I could be wrong, but around there. Anyways, you get a sense. If you're in a game, you have, let's say, 15,000 polygon count for an in-game character that's animating. How much would a cinematic character be? Well, it doesn't really matter. You know, if it's in cinematics, you know, the character can be a whole bunch more. And why is that? What's the difference between in-games and cinematics? Yeah, there we go. Elizabeth and Hamdi have it. So in-game is actually using the game engine, so it's real time. And then cinematics are pre-rendered. It's just a movie that plays back. You know, movies don't take a lot of memory. I mean, you got to store it. It's, you know, whatever. It's not a lot. Real time, that means, let's say for, as Jason was saying, 30,000 for Uncharted. So that is 30,000 polygons for a character moving in the game. It has to be rigged and animated and flow, and the face needs to deform, all in real time according to everything that you're doing. Cinematics is pre-rendered, so everything is set in stone already. It's just, it could be, you know, whatever. You send it off to a render farm, and they just chunk through it. You know, it's basically like Pixar. It's just a movie. You know, you render it, or over at ILM, you send it off to the render farm, and maybe one frame is done a day. You know, but you have, you know, thousands of computers rendering frames. So it doesn't matter. And film is like cinematic, only they just spend more time on it. So it's just pre-rendered. So the polygon count could be a lot of different things here. And we're going to talk about that here in a second, pre-rendered. But 3D printed, what's your polygon count there? You're just competing with atoms. You know, do you need 30 million polygons to 3D print something? Well, maybe. If you're using a printer that's going to catch all that detail down to the pores. It all depends on what your end goal is what I'm trying to say. Your polygon output is kind of important in this discussion because subtools came about because of a particular dragon movie and some of the requests that we had there. So you'll see it in the pre-recorded. The director had a dragon that they wanted to start really small, and then as that dragon kind of zoomed in, you basically saw the scales of his belly fly by the screen, and do that all digitally, and the sculptor wanted to do it all in the sculpt itself. So if we were to say take a dragon with that dragon tail, and I think it was a two-headed dragon, and a massive wingspan, and you wanted this little bit of the guy to fit the entire screen. That's 4K by 3K. So what's the math there? It's a lot of polygons. What is 4096 times 3096? That's the amount of pixels that are represented by that screen. Anybody want to do the math for me? I don't have a calculator handy. My iPhone seems to have disappeared. 12 million, Roberto says. So that's 12 million pixels. And pixels equal polygons. For every pixel of color and shape, there would have to be a polygon of color and shape. So that means that this area would have to be probably around 10 million. And I say 10 million because you have to apply an 80% efficiency. UVs, on average, 80% efficient in their use of space. You know, it depends on the UVs you use, but all UVs have distortion built into them. So 12 million times 80%, you know, see what you get. Let's just say 10 million. So now you can imagine there's 10 million, that's 20 million, that's 30 million, that's 40 million, that's 50 million, that's 60 million, 70, 80, 90, 110, 120, and we haven't even got to the side, the back, the head, the tail, the wings, or the side, the back of the head, tail, wings, head. None of that. So this model you're looking at is like a billion polygons. A lot. What feature inside a ZBrush handles a billion polygons? Built, or it was conceived to handle this problem. It hasn't been fully implemented, but there is a feature that was designed to handle this problem, and it came out of this discussion with the artist and that film. So Geometry HD is a billion polygon solution. It has its issues and its working methods. So we're not going to get into that right now. But what you're noticing is this polygon, this polygroup versus subtool discussion revolved around the polygon and how many polygons you need. So subtools allow you to get, let's see, 8 times the amount of polygons that your computer could normally handle. So if your model can handle, if your computer, sorry, can handle, let's say 8 million polygons, at about 64 million, your computer is going to start crashing, slowing down, becoming inefficient, and just not working properly. But you got more than 8 million, you know. You got somewhere between 30 and you got somewhere around 40 before things start to really get bad. But that's still, as you saw from that dragon example, it's still not enough. If somebody has a dragon that they want way far out and zoom it all in and they want it to be HD, and then on top of that, what the hell did they just invent? Something like a 4 times HD, the 4K, it's the 4K TV, and then we're just kind of moving into, like, what is the red shoot at, the red cameras? I mean, we're heading into a world where pixels are freaking atoms. Excuse my language. Resolution is increasing, and so here's the fundamental truth I like to tell people. Polygons are like money. You can never have enough. Even a billion's not enough. I mean, a billion, what's that going to get you? A yacht? 8, 10 houses? Full-time staff of maybe 7, 8 people, plus personal staff. A couple of companies. But, you know, go read up on Ted Turner. He's doing well with $2 billion. But, you know, he's not doing as well as Warren Buffett. Or Bill Gates, who's given away half and still is one of the richest men on the planet. So polygons are like money. You can never have enough, in the sense that polygons are what we deal with every day. You know, you always want more, you always need more, and so a lot of what we do is to get around that limitation. A lot of the workflows we do are designed to make the most of of what we have. So subtools is one option. HD geometry is another option. But it has overhead. It's complicated. It's not easy. Subtools are easier. Polygroups, much easier. And that's just the trade-off that we deal with. You know, things get more complicated as we kind of go up the spectrum. So you can use subtools like this, where they just separate things like the eyes. It's very convenient, because you can always just press G for solo, and you can look at the eye, come over here to the teeth. I've got solo mode on, which is down here. G is in George on the keyboard. And you know, I can adjust if I wanted to kind of mess with some things, pull some canine teeth out. Where's the canines? Where's his head orientated? Dun, 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 there they are. Oh, I don't have symmetry. You know, as you wish. Go into the kimono, press F, the gloves in this case. The kimono is right there, Ryan. You can sculpt these guys individually. You can work with it here. That's the main thing that subtools allow us to kind of do. But if we go back to our model, let's go back to delete. Even if we dynamesh this model, we're at 250,000 polygons, and let's say we want to add hair. So I add a sphere in here, something to add some hair, and I'll move this in. Use the move brush, and then Mike's got this neat trick, which you can see in his webinar, where he's using the clip brushes. So I'll press Control Shift. You can see I've got these slice, trim, you know, all of these kind of different brushes that we can kind of use here. I'm going to use a slice curve, Control Shift. You can see what it does. Keeping symmetry on. Okay, slices these guys out a little bit. Can I dynamesh these as groups? Let's do this. I'm going to undo that. It's all here as one piece. I'm going to separate this now. In fact, let's go backwards. I have this technique I want to use now where I kind of take these individual chunks and I kind of separate them out into their own pieces. So I want to do that, but if I use this feature, Dynamesh groups, and I Dynamesh, then it separates everything. The computer's going to slow down. Give it just one sec. There we go. So now what's happened is all of these parts have become separated pieces of geometry. They're no longer connected because groups is a Dynamesh feature that kind of breaks things up. I want to do this, but I don't want to do it in this way. I want to make some kind of change. So I don't know, let's just undo this. Is there another way? Yeah, let's turn group off. Let's say instead of doing it that way, I'm going to introduce you guys to another feature. Brush, auto masking, mask by polygroup. So now what I'll do is take little pieces and kind of push them in and out. Don't dynamesh though, because now I want this hair to be more. There we go. There we go. Okay. So now I want to really work this hair, but I don't really want to divide the hair. I mean, look at that. They're different resolutions. This is one size. These are another size. So my topology is not lining up. Now I need to separate this stuff. So how do I separate it? So glad you asked. There's a couple of ways. And what I'm going to do is just a manual approach. I'm going to hide things. So I'm going to Control-Shift-Click. I got to come into these guys, select the select rectangle. And that's it. Process you saw earlier. Okay, now I've got just the hair visible. So I come down here to Subtool, Split, and I say Split Hidden. And that creates a separate subtool there, and the hair is here. Now, this is not the best way to do it. Notice how the big guy is at the bottom and the small guy is at the top. That's not a good best practice. The top subtool retains top secret information about your ZBrush tool and is used by ZBrush to calculate the ZBrush units, the world space, a whole bunch of stuff. So in general, now I can't undo. It's this funny thing. They say you can't undo the subtool split. You can undo, but you get this weird thing where the subtool's still there. You'd have to manually delete that to get rid of it. But you can undo a subtool split. But essentially what I want to do now is I'm going to invert it. So Control-Shift-Click and drag so that the hair is hidden, and then I go Subtool Split, Split Hidden. Sculpt the hair separately. Also, divide the hair separately. Divide, divide, divide. On from there. And now we can get in and start to use clay buildup. And symmetry with hair isn't going to function. In fact, we can turn that other subtool on. Let's turn solo mode off. This is a nice, easy way to do it. Now, another way that we could do the hair is instead of using the slice brush like I did, there's another feature like trim, which is kind of really cool and can kind of help create better geometry. But this will get us going. Now I have mask by polygroup on. So I'm going to turn that off so I can kind of sculpt a little freer. Now, one trick with the clay buildup, you notice this kind of annoying, right? Come into stroke, lazy mouse, and you set lazy step to 0.05. Let me smooth all this out so you can see what it'll do. There. You won't get that same stepping. Sometimes you want it, but not always. Okay, we're butting up against our time here. Okay, so that was a real simple example for how we use subtools as also the primary reason for it, which is, in this case, I want this hair to be more polygons. If I'm to get into the level where I'm doing individual strands, let's say now it's 2 million polygons. So if I go into standard, let's say standard brush, and let's select an alpha, I go 6. And lazy mouse is on, so I'm going to take that lazy step way down in order to get the result that I really want. The polygon count has to be there. All right. And he's at 2 million. We would have to take it we would have to take it at least here to get even to get more detail. So let's cap it right there, guys. Let me check in with you and see how you're doing. And while you're writing questions, I'm gonna chat just a little bit to summarize things. So we had a bit of a journey today. We talked about the maquette process. We used an insert brush plus move. Okay, used a lot of poly groups. We talked about visibility and how to select your model, that whole control plus shift thingy. Okay, we talked a little bit about subtools, the polygon debate, the great polygon debate, and then just, you know, how to use them. So in split and on from there. When we were talking about the maquette, we were also talking about workflows. And remember, workflows are there to make you and I smarter. Don't go the rough road, the hard, just the kind of do everything by hand, manual approach, unless you have to. It's a good learning lesson, but there's, I know when we're learning, a lot of times I have all these preconceptions and I kind of push myself to do things too hard, so it takes a long time to get everything. Too long sometimes. All right. So your homework and your assignment is to continue to work your model. Make sure you check your lessons, but I would love to see now a full character being developed, a full part. In general, I think a full character is what I would really like you guys to do. I do recommend doing a character from reference, something that exists out there already. It's easier to know. You can kind of follow the design better. Harder for me to do that kind of stuff because there's all kinds of IP and permissions and yada yada. But you should do that. And that just really helps you learn the design language of other people. The lectures that are already there will actually walk you through how to use reference and the grid and all of that. And I think they're pretty solid. So I didn't really want to redo those. Okay, looking through questions. Let's see, Mitchell, can you elaborate on the top secret info about the subtool? It's really kind of not. But it's the key thing is just in fact the thing that's really relevant is it holds the scale information. It gets captured in here. So what can happen is let's imagine that this box represents the entire ZBrush universe. Everything that ZBrush can calculate is within this box. If the largest part of the model was the hair, and the hair took up this much space inside of that ZBrush world, then as soon as I add the head and the body, as soon as I get to the shoulders, it's outside of the known ZBrush universe. There are ways to deal with it when this happens, but you have to keep in mind that ZBrush is a benevolent dictatorship, and it has boundaries. Once you are outside of those boundaries, then you are no longer a comrade. It's not a friendly position. The software does not behave well. So the better option is that the body is the known equation, and then you just add hair. Hope that helped, Mitchell. Rebecca, you could create an écorché. Did I say écorché in that one? I'll look at the assignments and I'll make that very clear. If I remember right, it's human écorché, animal, or bug. But really, for me, it's character, and as simple as that. It's all as simple as that. Toony or anatomically correct. This is, guys, keep in mind, this is the CERT program. I'm here for you and your sculpting needs, so it's really hard for me in a program like this to tell you exactly whether or not it's anatomical or Toony, because people come to this program from graphic design, from from all spectrums. So what I want you to do is a character, full body. Rebecca, can you recommend a book of anatomy somewhere? I can 100% recommend a book. I'll give you my book, the Bible, the Times, Atlas of General Musculo. When I say it slowly, I I lose it. Skeletal anatomy. I'm typing this into Google in another window, and I can't bring it in there because I'm drawing. So escape out of that. There you go. Expensive book. Get the one with the hand. I bought one that did not have the hand. It was not the right book. It's quite annoying. These guys, they're in Germany, I think. And this, it's seriously the best, it's the best book. I wouldn't even, you can get artistic anatomy books, but this is the one that is artistic and scientific. It has cross sections, has information about, for example, how the trapezius has 3 portions, the ascending, descending, and the transversal, and then also the flow of the muscle fibers, stuff that you can get in the artist books, but not as solid a quality as this. See you, Riley. All right, Preacher, look forward to the new head. And Jason, just the Google. Yeah, right. I mean, do I send you the link or do I send you the anime? The problem, let me see what I can do, because there's another one that has a slightly different cover, and so I'd have to verify before I 100% say that's the link. I'd hate you to buy something that's not the right one, like I did. Any questions before we go, guys? Have a good week, David. Have a great weekend. Have a really awesome Father's Day to all the fathers out there. Thanks, Lonnie, for the link. Thanks, Jack. Thanks, Chris, Frank, Joaquin, Frederick. All right, for those of you in Paul's class, it's coming right up. Greg, when will this be posted? They're going to work on it right now. It should be today, barring, any problems, but it should be today. Oh yeah, if you're in Danny's is coming up. Simon, I've left Dynamesh and subdivided. Do I need to go back to Dynamesh to add the rest of the body? Simon, yes, you will have to go back to ZBrush, but to add the body. But what you can do when you go, you basically freeze your subdivision level, Simon, and then add the body and all of that, and then click freeze to undo all of it. That's what that button's for. Hey, Lesla. Hamdi. Mitchell's got a great link. Site's been around for a long time, collected a lot of awesome stuff. Thanks, Jose. Carlos, not sure what you said here. I suppose to see the week 4 before do the assignments. By week 4, do you mean week 4 because we're in week 2, or week? Oh, you mean module 4, right? Because it's a little. It says week 4. Don't worry, I'm working on that whole week module thing. Use them as you wish. The tests do cover largely the pre-recorded content, but I try to make sure to hit all the main points as we discuss it here. I just take a different tact. And in this case, I didn't talk to you guys about the grid and see through and how to use reference. Hey, Rebecca, great. The key thing, remember, guys, you're not judged on your sculpting here. This is your place to sculpt without the judgment. I'm here to help and to make your experience with ZBrush better, and hopefully your experience sculpting better. I might use anatomical terms when I comment, but don't let that detract or stop you or set a level of expectation. I know anatomy is a very heavy thing. It uses Latin, and like we just, culturally speaking, we have anytime we hear Latin, we're either in trouble or we're in over our heads. So it's not usually, a comforting thing. Comfortable words are not Latinate words. So don't let the anatomy get you. I say it so that you look it up and Google it. I'm expecting you to Google it and to just extract what you can. Greg, the best setup for brushes, I use default. I don't adjust. Marco, it's unlikely that the assignments that we're going to string them all together into one. Just because of the nature of the class, not everybody's in character, and sometimes graphic designers use ZBrush for different things. So the nature of the cert, it doesn't lend itself well to one project throughout the whole thing. Ignacio, how do you mask the entire model? Well, first you'd have to control-click to, let's make sure we're in a subtool that works. Control-click does it. But if you've got a partial mask, you have to control-click and drag, and then control-click. Character does not have to be human, Mitchell. I'm really, since I can't put a lot of restrictions on you or whatnot, my goal is guidance, and that's just characters. Human, anime, animal, logo design, some kind of character logo design, something like that. Carlos, you have a question. It's a good thing you posted that there. I was about to close it. No worries, I understand, Carlos. I'm not a good Spanish speaker or a very good Norwegian speaker. So I just have the fortune of being born where we speak English. So your question is about the écorché. Carlos, I'm going to edit the assignment so that it's much clearer. So check it in about 10 minutes. We're just going to edit it to say create a character. Lonnie, we'll get the tests to you guys in, I think, a week. But right now we're just getting to know each other. This is a second date. I don't want to, I don't want to test you right then. Carlos, an écorché is no skin. It's literally, if I know correctly, it's French for flayed figure, which means they took the skin off of somebody. Why that word is in French, I don't know. Makes me wonder about the French. That should be a Latin word, like, from the old days. See you, Greg. Have fun. Enjoy Paul's class. Marcos, there is no crit. If you need crits from me, I'm posting on every project. But the cert doesn't lend itself well to a crit because I'm not judging your work. I'm here to talk and get you going on things. So the way we do it is email, call the office. It's a little more one-on-one that way. Anyways, not everybody comes to the cert wanting a crit. So in the past, it didn't make a lot of sense. So if you need, Marco, if you need something specific, if you want something specific, not need, sorry. If you want something specific, email, call. You can also just tell me in your project because I will be looking at those. All right, guys, I better run, let everybody get set up for the next round and go have lunch. So have lunch or dinner or a cookie before bed, depending on what time zone you're in. Again, happy Father's Day to everybody, and have a fantastic weekend. And post projects. Keep working. The goal's not so much to, how do I say it? The goal is work. As artists, the only way we get better is we do the work. Feedback helps. All that stuff helps. Nothing helps as much as doing the work. Ciao, ciao.